Hello friends, welcome back to our channel. So today we'll discuss about one more concept in computer networks, that is HDLC, high level data link control, so which belongs to the data link layer. So HDLC, high level data link control. So this is a protocol used in data link layer. Okay, so the main design issues of a data link layer is a flow control and error control that we have already discussed, right? So flow control and error control. So the main purpose of this particular protocol is framing. Framing means if the data is more, and that data will be divided into different parts, and each part we call it as a frame. So that framing, and as we know, the flow control, error control. So already we have discussed about this flow controls and error control, right? So all these things will be managed by this HDLC protocol. Okay, and mainly this protocol will be used in transmitting the data between point to point communication as well as multi-point communication. Point to point and multi-point communication, where point to point communication means there will be a dedicated path between source and destination. Okay, there will be one destination and there will be a dedicated path. And coming to the multi-point, here the name itself indicates a shared link will be given to a multiple receivers. The sender will be one and receivers will be more, which are sharing about the common link. So this HDLC protocol will be used to transmit the data in both the communication, that means a point to point communication as well as multi-point communication. And also the main feature is it supports half duplex and a full duplex mode of communication. Half duplex and full duplex mode of communication, right? Yes. Now we will see the HDLC frame, how the HDLC frame will be represented, and we'll see each and every field of that HDLC frame. So HDLC frame. So the first one, that is a framing, right? So the data, and one more, this is a bit oriented protocol. It's a bit oriented protocol. Bit oriented protocol. So we know that the lowest layer of OSI model will be the physical layer, and from the physical layer it moves on to the data will be moves on to the data link layer, right? Yes. So HDLC frame, the fields are the flag. The first one is a flag, address, control, payload, FCS, and a flag. So these are the fields available in HDLC frame. See. So here the flag represents starting and ending of a frame. So in order to recognize the starting and ending of a frame, the complete frame will be added with flag on left hand side and flag on right hand side. So it begins with the flag and it ends with the flag. And this is a fixed format. So it is 0 followed by 6 ones and 0. So here the value of flag is 0, 6 ones and 0. Here also 0, 6 ones and 0. And the length of the flag will be 1 byte. The length of the flag is 1 byte. Okay, and coming to the address, here the name itself indicates address means the address of the receiver station. Okay, so it is an address of receiver station or host, whatever it may be, the receiver from which we are sending, right, to which we are sending, right? So address, and it will also be represented with 1 byte. So sometimes it will be also the multiple of 8 bits. Okay, it usually represents 8 bits. So 1 byte means 8 bits, and sometimes a multiple of 8 also, 8 bits also. And the next one is a control. Control. So the name itself indicates it is responsible for flow control and error control, and specifically it gives types of frame, type of a frame. So this is a normal frame format. There are multiple frame formats. So the type of frame will also be represented by using this control bit. Okay, let us see what are the different types of frames here. I'm erasing this one, right? So control bit, we are discussing about the control bit. Control. So there are 3 types of frames. So I'll write here types of frames. So frame is this one. Frame is this one. So types of frames, there are 3 categories. One is I frame, S frame, and U frame. So I frame stands for the information frame. Okay, so information frame. And this information frame name itself indicates it will send the actual data which user wants to send to the receiver. The actual data will be sent to the I frame. So whatever the frame we have drawn on the board is an information frame. So in this information frame itself, it also have the control of flow and error control. So bits represent the flow of control and error control. How to know whether this frame is a iframe or not? So the first bit of this particular control bar, control field is 0. Then it specifies this is a iframe, information frame. And coming to the next one, that is a S frame, which is a supervisory frame. Supervisory frame. So the name itself indicates it supervises the information frames. So that mainly concentrate on the flow control and error control. The flow control and error control. So sometimes it may send the data, and mostly it doesn't send the information, actual information. So there will be an absence of this payload here. It will only send the flow control and error control bits. Okay, so there will be no data, no actual data. So I'll write here, no data will be sent here. And how it represents, I mean how we know that frame is a S frame. So first 2 bits ER10. If the first 2 bits of this control field is 10, that implies this is a S frame. And the next one is unnumbered frame. Unnumbered frame. So this frame will give the link management. So here the link management means the name itself indicates it will be giving about the connection establishment and connection termination. Okay, so apart from the data, actual data, it will also give the information regarding the connections. So it's a connection establishment and connection termination. So both connection establishment and connection termination. So here how to recognize this unnumbered frame. So similar to our supervisory frame, if the first 2 bits are 1 1, that implies this frame is an unnumbered frame. Okay, and the size of this control bit will be 1 byte or 2 bytes. 1 byte or 2 bytes. Okay, and so this is the about the control bit, which is mainly used for the flow control and error control. And apart from the actual data which we are sending, it will also send the information regarding the error control and as well as the link management. And our next category or next field is a payload. So the next one is a payload. So here the payload is the actual data. So payload is an actual data or information which the sender wants to send to the receiver. So that actual information we call it as a payload. So this will be the actual data which the sender wants to send. And the size of this particular payload will be a variable size. So we can't say the size of this one. It's not a fixed, it's a variable that depends upon the bandwidth. Okay. And the next one is a FCS. FCS means frame check sequence. Frame check sequence. So here the name itself indicates this will be used for error correction. Okay, so error control, simply we can say error control, because the error control itself gives both error detection and error correction. So mainly this is for CRC bits for error correction. Okay, and the size of this FCS will be 2 or 4 bytes. 2 or 4 bytes. That means either 16 bits or 32 bits. Okay, and flag as usual, whatever the flag we have included in the beginning, the same flag will be included in the end in order to recognize the frame. Okay, the starting and ending of the frame, and it is a fixed as we said. So it is a fixed value. The flag will be 0 followed by 6 ones and followed by 0. So in both the cases, in the starting and ending, that will be appended with this one. So hope you understood the complete structure of the frame. Okay, so flag, address, control, payload, FCS and a flag. Now what are the modes of operation that this HDLC protocol can be implemented? So modes of operations. So mainly this HDLC can be implemented in 2 modes of operations. The first one is NRM. NRM means normal response mode. It's a normal response mode. So normal response mode means if there are a primary and secondary or sender and receiver, so receiver doesn't have any permission to send the data on its own until it gets the permission from the sender. Okay, simply we can say it as a half duplex. Okay, at a time only one way of communication can be done. So similarly here normal response mode, the sender will send the data and the receiver will be sending the data only with the permission of the sender. So simply we can say it is a master slave architecture, master slave architecture, until the sender gets the receiver gets the permission from the sender. The receiver can't send the information. That's a normal mode, response mode. And the second one is ABM, which stands for asynchronous balanced mode. Asynchronous balanced mode. So it is a quite opposite to the NRM. So at a time the sender can send the messages as well as the receiver can also send the messages. So this is similar to our full duplex. Okay, so here we will be calling it as a master. So both the sender and receiver will be having the same privileges. So at a time both can send the messages. Okay, so these are the different modes of operation that HDLC protocol can be implemented. So quick recall the frame structure, which is the first one is a flag which represents the starting of the frame. Address, it gives the receiver's address, and control bit specifies the type of a frame. So whether it is a I frame, S frame or a U frame, and a payload which is an actual data which we want to send, and FCS frame check sequence which is used for error correction bits, and finally the flag, once again the flag, right? So hope you understood this HDLC high level data link control protocol. It's a bit oriented protocol in data link layer. So let us stop here, and if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.